Hi, I'm Charlie Chang. Here I'm going to demonstrate how to use my code in R. As you can see here, I separate the code into different parts for the convenience. Firstly, we need to put the Excel file wide quality into a right path. Here is its address on my computer. After that, we can execute the Power code here. And you can use the keyboard shortcut, which is Control plus Enter to execute the code here. As you can see on the right-hand side, the data set is already passing to the program, and we can utilize that later. And secondly, I'm going to execute the part 2 code, and we will see the result. Here we will calculate the correlation coefficient between each explanatory variable and the response variable, which is quality. And for the visualization, print a table here, and also a bar plot for the convenience to compare correlation coefficient between each explanatory variables. And thirdly, here I'm going to execute the code here. We pick out the strongest two explanatory variables, build up least square regression model, calculate the formula of the least square regression line, which you can see is down here, the formula of the regression line. And here is another one. Here's another formula of regression line. As you can see here, the value has changed. And in part 4, we can use the least square regression model that we just built in part 3 and visualize scatter plot with a least square regression line. As you can see down here, it's the scatter plot of quality versus alcohol. And also you can draw a scatter plot with standardized X and Y axis. And here, this one is another scatter plot. It's the scatter plot of quality versus density. And as you can see here, we got an outlier here. And for the code here, I tried to remove the outlier from the data set. As you can see here, the index of the outlier is 2782. So I remove it from both the data set and draw the scatter plot again. Oh, here you can see the difference. The outlier is gone. And in part 5, we can use the least square regression model that we just built in part 3 to calculate the residual of it. And here I'm going to execute the code here. And it will draw a residual plot. As you can see here, it's the residual plot of quality versus alcohol. And here is another residual plot. As you can see here, it's the residual plot of quality versus density. And in this part, we are going to calculate the standard deviation of residual for both models. And as you can see down here, we got the two standard deviation of residual for both model 1 and model 2. And the next part is to calculate the coefficient of determination for both model. And as you can see down here, this one is the first coefficient of determination for model 1, and this one is for model 2. In part 6, we will conduct a random sample to select 450 observations from the population of X, which is alcohol, and Y quality, and check conditions. And this is a scatter plot of the random sample. As you can see here is the sample size is 450, and we got a new correlation. And this one is a residual histogram for of the random sample when x equals to 10. And this is a residual plot of the random sample. And in part 7, basically, it will build the least square regression model for the simple random sample, which n equals to 450. And calculate all the parameters that we need to build up a 90% confidence interval. Parameters like slope of the least square regression line. Yeah, here. And also the standard error of the slope. And also degree of freedom. And also T star. And finally, we will get the outcome with a 90% confidence interval. The slope should lie between the particular interval, which is 0.27 to 0.37. And finally, in part A, uh, it will calculate the t-test statistic and p-value, and we can utilize them in our linear regression t-test. As you can see here is the t-test statistic and also the p-value. Okay, here is all my demonstration.